Hey everyone. Today I'd like to talk to you about front-end infrastructure teams and why the addition of them to your company can result in a significant productivity boost to your team. And if you already have a front-end infra team, then great, but hopefully you might pick up something about how we run ours at Intercom and how it's directly influenced by how we build product for our customers. So I'm Pat O'Callaghan. I'm a staff front-end engineer in Intercom, and I work in a team called Team Front-End Tech. And if you don't know Intercom, we're a customer service platform which allows businesses to deliver fast support and maintain close relationships with their customers. So you may recognize on the bottom right-hand corner from your travels across the web. But besides the messenger, beneath the surface are actually a good deal more than that. So we have this application called the Teammate app, where admins can interact with and manage all their conversations with their customers. You can manage bot automations. You can also view reporting to see how your customer support team is doing, and many other things. So this Teammate app is built with Ember, and my team, Team Frontend Tech, we mainly manage all the DX and tooling around this application. So the Teammate app is like a 9.5-year-old monolith with roughly around 700,000 lines of code. It's a single application in a single repo with some external private packages like design system and some other libraries. But over the 9.5 years, we've seen the app grow immensely, as well as the number of engineers working on it. So we currently have over 150 engineers on over 30 teams contributing to the code base. So here you can see the number of contributors to the Teammate app code base over those years. You can also see the number of routes have increased as the app has got bigger and more complex. And then the number of components has also dramatically increased over that time. So you can imagine during the growth of the code base over those 9 years, a lot of stuff had to happen besides regular product development to keep the code base healthy and the product team happy. For example, like these are many of the extracurricular things that needed to happen alongside regular product developments in order to keep the code base healthy and well maintained. So in the early years of the Teammate app, everything was smaller, more maintainable. Everything was predominantly done the same way. Opinions were somewhat set in stone and followed wider community opinion. And the comms were easier as the eng teams were much smaller. All the extracurricular work was done by engineers as part of their regular product engineer roles. And it was easy to scope this type of work as the tasks generally didn't take very long due to the smaller team and code base size. And at the time, maybe our product owners didn't even know we were doing this type of work because we managed to do it alongside our regular product work. And it's worth pointing out that Ember helped us immensely during these early years. The Ember community was essentially our front-end infra team. Opinions, tools, and problems were all solved at the community level. And there was just nothing else on the market like it with its batteries included ethos. And this just allowed us to focus on product and move fast. Then as the app got older, things got slightly harder to do. So teams got bigger, the code base grew, time passed and opinions changed on how things should be done, both in the community and internally. So what was once best practice had now diverged to newer and better best practices. And then communication and keeping everyone on the same page grew more difficult due to the team size. So improvements which before would have taken a short amount of time now took longer to do due to the size of the code base. And this meant product engineers could no longer just do it. To do this work, product engineers needed to take more and more time from their regular product team duties. And with that, there was more pushback from product owners who questioned what these tasks had to do with their product team's roadmap. So we ended up just shipping things which were small improvements, or maybe the tasks grew in scope and ended up being half completed or just not shipped at all, as the borrowed time the engineer had ran out. So relying on product engineers to double job on infra improvements meant we were always at the mercy of product. And I don't think that's necessarily wrong. If a product team's charter is specifically for shipping value to your customer, it's a hard sell to your product owner that you should spend a significant portion of your time working on things not directly linked to your team goals. So with these constraints in mind for product engineers, what ended up happening a lot was larger pieces of impactful infra work were just dropped for some quicker, cheaper thing to fit into a smaller time frame. And this is what we refer to as snacking, and our product teams try to implement a no snacking policy. So to explain this concept of snacking a bit more, let's visualize the idea of impactful work with this 2x2 graph. And we have effort versus impact on the two axes. So on the top right represents the core of the company strategy, or things which really improve our engineers' productivity. And it's where the hard but meaningful work exists. And this is what really drives our company forward, and where we would hopefully be spending most of our time. The bottom right, we wanted to steer clear of. This was high effort and low impact work. There's nothing of value to be working on in here. The top left represents where everyone loves to hang out. The low effort, high impact work. Early on, there's a fair bit here, but it quickly dries up as the app matures. And then we have the bottom left quadrant. This is low effort, low impact work. And we refer to this as snacking, because if you never eat anything of substance, you suffer. So it feels rewarding, solves a short-term problem, but long-term, it's bad for your health. It's at this stage, the low effort, high impact stuff has dried up, but product engineers don't have the time and space to focus on the longer term, higher impact work. So they just continue to snack on easy, low impact things. So to see what this looks like with actual examples of work we did over the years, let's fill in the various quadrants. So if we just focus on items in the low impact areas, we're missing out on working on things which actually improve the code base and make engineers' lives better. The result being building is no longer frictionless and becomes an impediment to moving fast. So teams start moving slower, which in turn has a direct impact on how much value they are delivering customers. And over the years, this lower quadrant is where we kept finding ourselves at Intercom. As the application had grown, product engineers didn't have the time to work on the bigger, more strategic items. Thankfully, over time, we had progressed from just having product engineers doing this work to having 1 or 2 engineers inside a larger infra team focusing on it. But the low effort, high impact work dried up quickly, and we kept hitting the same problems and ended up in the bottom left quadrant. We had a high bust factor, which meant progress was frequently interrupted. Unless items were deemed critical, like adopting Octane, we simply struggled to stay the course and make progress. So we wanted to spend time in the top right quadrants, but found it difficult to stay there. It finally got to the point where we were multiple years behind on several key dependencies like Ember Data. The developer experience was becoming a burden for product teams, and shipping was being affected negatively. But why is shipping important to us at Intercom? In Intercom, all of R&D is guided by a set of principles which underpin all our practices for how we build and ship products. So taking any feature we build, we have a North Star, the problem we are solving, and iterate towards it. We don't need to know all the answers up front. Trying to know them can hold you back. We ship, we get feedback, we iterate, rinse and repeat. We try not to do big bang releases, but instead ship incrementally, because when we have in the past, we've tended not to have solved the customer's problems correctly. So this is a quote from one of my favorite blog posts on the Intercom blog. It was written many years ago, but its influence is still felt throughout the company years later. Shipping brings life to your team, to your products, and to your customers. Shipping is your company's heartbeat. So if we struggle to ship, we struggle to learn, and therefore we struggle to solve our customers' problems. Essentially, if our heart stops beating, we die. And there's a seminal book which came out a few years ago called Accelerate, which documents the characteristics of high-performing organizations. So a quote from it reads, "Organizations deploying more frequently and maintaining shorter lead times are twice as likely to exceed performance goals as their competitors." So to succeed at moving fast, you need to have a strong culture of continuous delivery and getting features into customers' hands. At Intercom, we want to make building and shipping as frictionless as possible. Product teams shouldn't be wasting resources solving problems which don't directly relate to solving their customers' problems. The majority of their time and energy should be going into their core idea. So to improve shipping and make meaningful progress to stay in the upper quadrants, we finally decided to fully staff a front-end infra team front-end tech. We now had 4 engineers and a dedicated engineering manager, which gave us the space to tackle some of the high-impact work we'd failed to progress in the past. So we're finally managing to climb ourselves out of the lower quadrants and move into the top right quadrant and stay there. But we had a team now. How should it work? What should we work on? For the teams to succeed, just like a product team, we needed to be continuously searching for the highest impact items to work on. To have impact, we needed to work on what matters to our customers, the product teams. Our team must be indispensable and not deemed a nice to have. So I love the analogy of Ember being a framework which helps me start building from the 20th floor. Similarly, for our front-end infra team, we should be building on top of what Ember gives us and build things that matter to our product teams. We should be helping our product team start building from the 40th floor, and we achieve this by being specific about the work we take on. The reason our team exists is not just to do random upgrades or busy work. We should have a clear goal of being a force multiplier to our product org, and having this mission makes it obvious to us where we should be spending our time. Put simply, to be an effective team, we're going to need to pull our roadmap together from different sources, not dissimilar to a well-functioning product team. We needed to operate like a product team where the engineers of our org were our customers. We needed to be providing impact to them, solving their problems. So this is an image from an old blog post about how product teams at Intercom build roadmaps, and it's not a million miles away from how we think about generating our roadmap. Although let's tweak it slightly. Here I've changed improve quality for product health, as that's just how we think of this category. So generally, we see product health as a backlog of things we know we need to do. So typically, this ends up being large bug fixes or upgrades. Usually things like system-level upgrades like Node, or other key dependencies like Ember Data or Ember Source. And generally, this is chunky work, depending on how big dependency is. So we have a weekly on-call rotation, but sometimes if a dependency is too big or important for on-call, we'll add it to the roadmap specifically. Then we have new ideas. And these are ideas or experiments which we'd like to explore and take a bet on, which we think will pay off. So maybe it will involve a spike to validate the assumption before we actually add it to the roadmap. And we took this approach when we introduced Tailwind into our code base as a means of styling. We experimented with it ourselves, gathered feedback from engineers, did some technical spikes of how we'd integrate it. We shipped it, and the engineers loved it. Next, we have iterate, where we're iterating on existing ideas. So this goes back to our original R&D principle of think big, start small, learn fast. When we ship something, we shouldn't assume we'll get it right the first time. We may need to get feedback and then iterate on it. Maybe we ship the de-scoped version of something as a first iteration and are building upon it from here. And next we have features to help you scale. So these are items which can come from a number of sources, but are directly related to problems which appear as the company grows. So they look to help the code base, application, or company scale, or make the product more resilient. So the inputs of this could be cross-cutting concerns for R&D, top-down company goals. We also have a front-end working group where discussions there may feed directly into our roadmap. We also have a group of principal engineers where each is associated with one of the product group. And this principal group are drivers of a lot of how product engineering looks at Intercom. And their discussions may generate programs of work for our roadmap. So some of the projects in this category might be longer plays, but we need generally to earn the trust of those at the exec level and be able to defend the work. One consistent issue we've been seeing as our app scales has been the feedback loop for engineers, specifically around rebuild times. So here's an example of what we call an intermission, which focuses on improving the feedback loop. It's essentially a problem statement, why it's important to us, and what we consider a successful outcome for this work. So we've had several attempts over the years trying to improve the feedback loop, and recently we've gone deep trying to get our app up and running with Embroider. We're not there yet, but we've been making good progress and have 2 front-end tech members currently on the Embroider core team. Also, because this particular project is so important to us, we've jumped in and are supporting the Embroider initiative, which Marco talked about yesterday. We understand the importance of the Embroider project, not just for us, but the wider community, and are invested in seeing it succeed. Then lastly, we have customer problems, which is arguably our most important input. Similar to product teams who have customers, we treat project engineers at Intercom as our customers. And similar to product teams who speak to their customers, we speak to our engineers. We need to find out what's affecting their workflows the most. Some of the highest areas of impact can be gained by working directly on problems which are creating friction for them. So this example here is where developer experience survey surfaced a whole area of friction for engineers when it came to writing and running tests locally. We received lots of negative feedback from product engineers in the survey, and then to get more in-depth detail of their problems, we conducted a large number of in-person interviews with those who gave the lowest ratings. This gave us a program of work. Sorry, I'm getting the update. This gave us a program of work for a roadmap directly focused on tackling the issues raised. So how we balance all of these inputs and how much of each category ends up in our roadmap is constantly changing. It's flexible, as it always depends on current priorities and engineer capacity. So some roadmaps may see items from multiple inputs or only a single input, depending whatever is top of mind for us at the time. Which brings us to measuring success. So once we've identified the problems we're going to work on, how do we know we're solving the problems, or at least making progress to solve them? Measuring success is one of the trickier parts of having an enablement style team. Enablement and productivity are kind of fuzzy, and there's no single way we'd be able to measure this. So at Intercom in the Teammate app, we're currently shipping to production around 220 times a week, which is around 45 times a day. So we may see this value and try and do something like our success metrics should be number of deployments, number of PRs open, lifecycle time of PRs. But there could be any number of reasons why these numbers can be skewed, positive or negative, not directly related to the work our team is doing. They may be an interesting approximation of org health and used as waypoints, but they should never be used in isolation. So ultimately, measuring success should come from multiple locations and tied directly to the things we are working on, some less clear than others. And this is constantly evolving for us though, as we learn and navigate this space more. So saying that, we do use metrics, but we try to make sure that they are associated with core common engineer workflows. There are some things that are easy to measure, and we can at least try to hit or maintain a certain level of service. So we track the end-to-end CI runtime, because every time an engineer pushes to a PR, we know it's going to need to complete before they get feedback on whether it's safe to ship. In this case, we have a P75 of around 5 or 6 minutes. Similarly, end-to-end deploy times should be fast, so when engineers merge their code, they can expect it's going to be in production in a short amount of time. So here we can see from when an engineer merges their code, it's going to hit production in around 10 minutes. Another metric we like to look at is local build times. In this case, currently we're seeing rebuilds of files around the 12 to 13 second mark. We aren't where we want to be, but it allows us to experiment and incrementally improve our build speeds and track it over time. So we have a target and we're trying to get there. So in summary, CI, deployment, and build times are pretty easy to understand when we're not hitting the bar. Another way of measuring success is to consider company level goals. As Team Frontend Tech is trying to have high impact, we're pulled into projects which are cross-cutting across R&D org or top-down business objectives. In some aspects, they might not be as measurable as build times or deployments, but there should be some clear sense of what success looks like here. An example here was collaborating with our security org to remove all potential XSS vectors from our application and help introduce a happy path so engineers couldn't inadvertently reintroduce them. Even though we have CSP enabled, we still treat any reports of potential XSS vectors as a P1 issue. We worked with security to evaluate our codebase and replace any usage of unsafe APIs that could cause potential attack with sanitized alternatives. We introduced linting, training, and documentation for engineers, but ultimately the success of this project was a reduction in XSS reports in the Teammate app by pen testers. Then lastly, we have developer experience. So the most impact to be had can be gained by talking directly to the engineers we're supporting and finding out about the pain that affects them directly. Unfortunately, this can be hard to measure, but probably the best way to do this is through surveys. Every few months, we send out what we call a developer survey, which tries to get a pulse of the pain points that engineers are currently experiencing and how they generally feel about their workflows. It's a good gauge whether sentiment has improved for engineers or whether they're still seeing no improvements. But how do we actually conduct a survey? What do we measure? So we use something called the DevX framework, which was created by some of the same authors as the Accelerate book, which I mentioned earlier. And this framework focuses on measuring 3 key areas of engineers' workflows. First off, we have flow state. So this we know as engineers is that sense of when we get in the flow. Do we have distractions? Is the feedback loop causing us to lose focus? In general, engineers who experience flow state are more productive, innovative, and happy. Then we have cognitive load. This refers to the amount of mental processing required for an engineer to perform a task. High cognitive load impedes delivering value to customers. Rather than focusing on delivering value, engineers need to deal with problems such as poor systems or code, which means they have to dedicate extra resources to complete tasks or avoid mistakes. Then lastly, we have feedback loops. Fast feedback loops are a key indicator for good productivity. This can be feedback loop for both tools and or people, and shortening feedback loops has shown to increase overall productivity. So engineers with fast feedback loops complete their work without problem, whereas slow feedback loops lead to frustration and context switching. So having a survey based on these criteria, we'll get lots of wide-ranging satisfaction rating data over long periods of time. It tells us how productive our engineers feel and in what areas they're experiencing toil. We use the results from these surveys to drive our developer experience program, which feeds directly into the roadmap of a number of infrastructure teams, not just our own. But the most important thing is we can see whether our work is solving problems. And this brings us to the Team Frontend Tech team charter. The success of our team is directly linked to the success of the product teams we support. We supercharge product teams, enabling them to deliver value. To have the most impact, we need to be delivering for our customers. We have a clear goal of being a force multiplier to our product org. So putting all this together, how we think about the purpose of a front-end infra team, how we prioritize, how we measure success. I'm just going to cover some case studies where a small team had outsized impact for the product org. First up is internationalization. So our Messenger app, our Messenger has been multilingual for years, but up until 2020, our Teammate app only supported admins who are English speaking. This became a top-down company strategy to unblock non-English speaking customers to adopt us so we could move into newer geographical markets. While there was a wide collaboration across the company, Team Frontend Tech were tasked with figuring out the technical workflow for localizing the app. But all we had to do was install Ember Intel, right? Easy, job done. Unfortunately not. At the time, this was an almost 7-year-old code base where there was little to no consideration for internationalization. These were just some of the tasks we had to do to properly roll it out. We weren't going to be doing much of the localization ourselves, but rather the product teams were doing the bulk of it. It was a heavy lift with a lot to figure out. How are we going to localize the app from a technical standpoint? How are we going to integrate it into the existing product workflows? And how are we going to shift the product org's mindset to localization first? For example, we built this cool little debugging tool for engineers so they could tell what was left to be localized on any page, basically converting all localized text to hamsters. And this just made the migration workflow and being able to track the progress of what they're working on so much easier. The project was on our roadmap for over a year, was a massive cross-company collaboration and was a very visible project internally. At this point, we've made amazing progress with around 80% now fully localized. We still have a bit to go, but all the main traffic parts of the app are fully localized. The outcome in the end is that from an app that had little to no localization, we now offer admins the choice to use the teammate app in 5 separate languages, which has helped Intercom grow into markets we were blocked from before. Next, we have observability. So in Intercom, we talked a lot publicly about how we have a strong culture of using observability across our systems to improve availability and performance, giving talks about it and writing blog posts. Historically, though, this was only accurate from a back-end systems point of view. We had very good visibility and understanding of our Rails app and its related systems, but our understanding of how customers were experiencing the app and its front-end performance was not so clear. It was pretty much a black box to us. So we had a program driven by our needs to be able to understand how our customers were, or how our UI was being perceived by our customers. This also happened around the time of what we internally refer to as Inbox 2, a reimagining of our Inbox product, whose primary goal was performance and a superior user experience. We were part of a working group with a number of folks, including observability experts, principal engineers, and product teams, to try and figure out how to best introduce observability on the front end and what we should be measuring. So a big part of the observability solution we ended up with involves traces like this. These traces are a combination of back-end and front-end data, interleaved with one another, and also incorporating error stack traces if they occur. So we have the ability to trace our systems from the UI through the back-end systems and back again. And when customers report performance issues, we can retrospectively dig into their specific situation and see if we see anything out of the ordinary. So in this specific trace, customers were seeing a lot of slowdown in the rendering of email responses in the inbox. From a back-end perspective, all the APIs were returning really quickly, so the problem must have been the front end. In this context, long task is a blocking UI task, which is taking a long time and is blocking rendering. And this is what was being perceived as slow by the customer. Before having this tooling, we struggled to diagnose issues like this, where a customer was telling us things were slow for them, but the slowdown was specifically on the front end. So using this information, we managed to discover we'd introduced a bug into our client-side sanitization library, which was doing multiple passes of sanitization instead of one. We shipped a patch and then compared the results, which clearly showed that it reverted to previous levels of rendering. So in this case, the purple is the buggy code and the orange has the fix. And this is just one example of how observability has helped out, but we have many more. Even better, with this system in place, it's now possible for us to proactively discover performance issues without needing a customer to report it first. And lastly, we have CI. So as I mentioned earlier, we conduct surveys to better understand engineer pain points. One of these occasions, we managed to surface a lot of negative sentiment around the teammate app CI environment compared to other repos. So we knew the running time had regressed a bit over time, but didn't quite understand how much of an issue it was. So here we're being told by engineers directly with a really low satisfaction rating that this slowdown was causing major problems in their workflows. The slowdown meant they were context switching more often and losing focus. So the amount of feedback we got meant we had to prioritize this straight away. So just a quick bit of context. If you were to run our test for the end-to-end in our teammate app, it would probably take around 4 or 5 hours. So we split them using Ember Exam and run them over 210 buckets. As part of this work, we heavily instrumented our test suite to try and understand what was causing the slowdown. And essentially, we discovered that if you have 210 buckets of tests, your end-to-end CI time is going to be as quick as your slowest bucket. So when looking into it, we found there was a big variance between some of the bucket running times. Some were taking 4 minutes, while others were taking 12. So then we looked into the makeup of the different test files to try and figure out what made the buckets vary so much. So by sending up the number of tests per module and their running times, we found that most of the longest running modules had a high number of tests compared to others, and that was why they were taking so long. So as Tomic explained to us yesterday, Ember Exam splits tests by file. Unfortunately, Ember Exam's load balancing feature didn't work for us here. For example, some integration test files didn't have many tests, while other integration test files had hundreds of tests and were thousands of lines long. So it was a crude solution, but we ended up coming up with a max number of tests per file and linting against it. We also applied a max file length to test files, so files shouldn't exceed a certain number. We then split all the test files which violated these rules and just to improve the bucket balance. And with this change, we managed to bring down all the bucket running times to around the 3 or 4 minute mark. We also started tracking the browser memory usage in our test suite and found a number of problems. So we had some severe memory leak problems. And in some instances, we were consistently hitting 3 or 4 gigs of memory used in the browser. And every time we hit 4.5 gigs of memory, the browser would panic and fail CI. So with that knowledge, we found one major memory leak in our tests, shipped the fix, and we're able to see immediate results in our metrics. Each vertical line in this graph is the amount of memory used by a browser in each test bucket. So you can see the difference in memory usage immediately after we shipped our fix, with the memory dramatically decreasing, but also having the side effect that our test suite sped up to. So we ended up reducing the P50 end-to-end running time from 10 minutes down to 5 minutes, a 50% reduction. But then the best part, over subsequent surveys, the engineers were very happy with the improvements we'd made. So in summary, as our company and codebase scaled, relying on product engineers to incorporate all the DX and infra improvements was a losing battle. Inevitably, something suffered, whether it was the product because our engineers were distracted from shipping value to our customers, or we could only manage to incorporate small piecemeal infra improvements. But having a group of individuals whose sole purpose was to force multiply our product org worked out as a better strategy for us. But when having a front-end infra team, the team needs to be working on the right things to be effective. We needed to understand the developer experience and what affected our product org the most. And then we needed to know if the work we were doing was actually moving the needle for our product org and solving their problems. If not, we ran the risk of not showing value and just being a nice to have. So we found all that interesting. I'd like to shout out that we're hiring at Intercom, specifically for our role on Team Front-End Tech, but also for a wide range of other engineering roles. So you can check out the details on the Intercom page. Otherwise, thanks. I love talking about this stuff, so if you want to have a chat, just reach out to me. Thank you.